and how UART works, and we are going to see like what are the registers to be configured on UART in 8051, and how to write a program for UART transmit and UART receive. Okay, and we are going to cover up introduction to SPI, and what is MCP3202, what is SPI ADC, and how it works, and we are going to cover the code for ADC data, to read an ADC data from a pot meter and display in UART. So these are the things which we are going to cover up today. Let's start the day with the mindset lesson. Like today, mindset lesson for the day is like ideas will not work unless you act on it. Okay? Where you could transmit only less number of data, whereas in synchronous data transfer, you could transmit more number of data. Okay, but it depends upon the clock. Okay? You could transfer bulk data on synchronous communication, whereas for asynchronous communication, like it is a frame structure by data. Okay, so what we are going to see today is an asynchronous data transfer. So coming to UART, like if you check this block diagram, like you have this transmitter. Okay, this is an FPGA or a microcontroller, where at the microcontroller transmitting port has to be connected to the receiver or a PC receiving port. Okay, receiving port, and the receiver of the PC or a host is connected to the microcontroller. Transmitter is connected to the microcontroller receiver port. Okay, so it is 9 bits. The parity bit would be on or off. Okay, and stop bits, you could also have stop bits and flow. What it usually the pin is high. Usually the transmitting pin is high. When it starts transmitting the data, the pin goes low. Okay, the pin goes low. That is a start bit. The first is a start bit, and then it transmits the data, 8-bit data. Then finally the pin goes high for stop for a certain period of time. Okay, so this width depends upon the baud rate. Okay, baud rate. So this is the the signal will be as high. The TXT signal will be high when during the transmission process, during when it is idle. Okay, when it starts transmitting, the signal goes low, and that is the indication of the start bit, and it will be low for certain period, and then it starts transmitting bit. Okay, so this period depends upon the baud rate and the clock frequency, like what is the clock frequency used for that microcontroller. Okay, so first the LSB is transmitted. Okay. So this is the basic schematic block diagram. Like the TTL level for logic 0 is 0 volt, and whereas for 8051, like the logic 1 is 5 volt. Whereas for the RS-232, TTL level logic 0 is logic 0 is plus 3 to plus 25 volt, and logic 1 is minus 3 to minus 25 volt. Okay. So you need a driver for converting this logic level RS-232 level, because personal computers, like they work on RS-232 level. So if you want to convert that to an RS-232, like you have to convert by using a driver max-232. Okay, and if you use a 3.3 volt device, 3.3 volt 8051, then you have to use max 3232. Okay, schematics, like the microcontroller, you use max 232 for a 5 volt device and 3232 for 3.3 volt device. Okay, so I will repeat once. Like UART stands for Universal Asynchronous Receiver and Transmitter. Okay, it uses 3. So if you want to transmit UART in 8051, certain registers has to be configured. Like you have to configure the power control registers and the SCON registers. Fixer baud rate, shift register mode for fixer baud rate. So mode 1 is 8-bit UART. So we are going to use 8-bit UART with timer 1 with determined baud rate. Okay, we are going to 8-bit UART. 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 8- to determine the baud rate. So it is mode 1. So we have to use SM0 and SM1 as 0, 1. So we have to configure 0, 1 here. SM2. Okay, SM2 is for multiprocessor communication. We are not going to use that. So it is 0. REN is receive enable. Okay, receive enable. So we are going to use that receive enable. So it is 1. And TB8 is 9th transmit bit. We are not going to use that because we are going to use 8-bit data, 8-bit Uart data. So transmit 9th transmit bit and 9 RBA8, bit 3 and bit 2. Bit 3, RB8 and TB8 we are not using because it is a 9-bit. It is used only for 9-bit Uart. Okay, and TA like transmit interrupt. Okay, transmit interrupt flag as well as receive interrupt flag. This will be set by the 8051 itself. Okay, and it has to be cleared by the set by the hardware. It will be set, this transmit interrupt flag will be set by the hardware, and the receive interrupt flag will also be set by the hardware. Okay, so we are not going to use that. So we are going to use 0, 1. This is 0, 1. Okay, and then REN is 1, 0, 1, 0, 1, and all this 4 zeros. Okay, all this 4 zeros. So for SCON register, if you check for the SCON registers, okay, SCON register 11.0592 megahertz. Okay, so this into 10 power 6 will give you this value. Okay, when you convert this megahertz to hertz, like it will give you 11,000. 11 lakhs and 1 crore and 10 lakh and 59,200. Okay, so when you convert that to hertz, so the machine cycle should be the machine cycle formula is like the crystal divided by 12. Okay, will give you 9,21,600, and timer clock has to be again the formula is divided by 32 to get the T clock. Okay, to get the T clock, you have to divide the machine cycle in divided by 32. That will give you the T clock, that is 28,800. Okay, so if you divide this 28,800 by the baud rate, you will get the value 3. So here is the formula, like TH1 equal to 256 bit 7 and 3. Okay, bit 7 and 3 is for enable timer. Okay, and M1 like 6 and 2 is for the timer 0, 5 and 4. This is for M1 for timer, and this is for counter. Okay, 20 timer mode registers 20, like 20 T. This is T mode register. Timer 1 and timer 0. Here we have to enable a timer 1. Like timer 1, we have to enable the timer. Okay, to enable the timer M1, like we have to set this T mode value as 0 into 20. Okay, then you have to set the baud rate in TH1 register. So baud rate calculation, like the for init. So where I have declared those values, and transmit a single character. Okay, transmit a single character, like I have moved this data to SBUF. It has to be like until like it will wait like TA, the transmit interrupt flag becomes 0. Okay, once a buffer is transmitted, it will become 0. So you have to reinitialize that on the software. So we have to reinitialize. So TA equal to 0, that we have to reinitialize. Okay, so this is a serial buffer register. So transmit interrupt flag, the bit this will indicate once the transmit is complete. Okay, and sets after transmitting a byte from the buffer. Okay, at the end of the 8-bit in mode 0 and beginning of the start, normally transmit is set by the hardware at the end of the 8-bit in the mode 0. Okay, so transmit interrupt flag. Let's go for the code. I'll explain the code in the presentation first, and then we will go for the tail, and we could try the code. First, you have to include reg51.h. Hash include reg51.h. For the, you have to define the 8051 registers. I have declared three functions Uart init where I have declared the where I configured the registers, and then Uart first to transmit a character I have a function which I will pass a character. Okay, so sbuff equal to data. It waits till the data to be transmitted. After data to be transmitted, it returns. Okay, it sends. So the next thing is send string, like void you would send string where you will be sending the string. Okay, sending the string like you would like the main program. This is the main program. First call the installation program. I have just put a simple while loop, and I'm going to send the string hello world. Okay, uart underscore send string is a function which I have written, which gets the pointer value from the pointer, and it transmits the character. Okay, so one by one. Let's go to the program. It's very simple. Let's go to the program. I'm opening the Kale micro. Okay, I'm opening the Kale. So I will create a folder on the desktop. Okay, so I have created a folder called Uart on the desktop. So I just copy this path, okay, and go for project new microvision project. Okay, so I will disable my face. Okay. So I change the path. I change the path to desktop, and I create a folder like Uart. Okay, so that all the files will be stored here, and the file name project file. I'm giving a project file name Uart. Okay, so first save. So I have to choose my device W78E05D 052D. Okay, I choose the device here. Click OK. I don't want any startup code to be added. Click no. So project, you go for view project window. So this will show you the project window. Else you go for reset view to defaults, like it reset the views to default views. Okay, and click add new item to group. Add a C file. I choose a C file here. Give the name of the file. I give uart.c. Okay, so this C file is here. Like I'll start writing the program. Hash include. So I will increase the screen size. Hash include of reg51.h. This is the header file which contains the registers. Okay, so void. So I put void uart underscore init initialization. Okay, so void main. Okay, okay. So I write this program like void uart init. Okay, so I have two more functions like void uart underscore tx char to transmit a character. Okay, and it should be like I'm passing a value character here. Okay, so void Uart send string, send the string. So I'm going to pass the cat. I am going to pass the data type is character. I'm going to pass the point as a pass this as a pointer here because it's going to be there on an array. We're going to send an array here. So I'm passing the string. Okay. So we have written these functions. So now let us go for the init function. Okay. Init function. You open if you have to ridge 51.h. If you open ridge 51.h, if you open ridge 51.h on the ridge 51.h, okay, this contains the registers like the tmod, tcon, pcon, okay, pcon registers, tmod and scons, all the registers will be here. So I'm going to use the tmod. It should be same. It should be same if the capital letter, whatever the things that there in the you have to use the same thing. Okay, this is timer 1. This is to initialize timer 1 mode 2. We are going to use mode 2 for 8-bit UART. TH1. This is the baud rate to set the baud rate as FD to set the baud rate as 9600 baud rate. And SCON 0x50. Okay, and TR1 equal to 1. So save the program. I just check this program. Okay. So we have completed the code for the UART initialization. Then to transmit the character is sbuff. Sbuff equal to data. Whatever the data it comes, you have to send the data here to sbuff, and it has to be wait till it transmitted, till the transmit interrupt flag is 0 equals 0. Okay. So this is sbuff has the data to be transmitted and data to be received. You have, till the transmit interrupt flag is 0. Okay, you will put pi equal to 0. So the next is send string. You get the string here. So I declare an integer. I declare an integer I here, and I put a simple for loop for I equal to 0. Str of I. Okay. It reads until the string, okay, equals 0 I plus plus. So you call this function here. Just transmit this. Transmit till the string. Okay. So let's go for the main program. Let's go for the main program. First, you have to initialize the UART. First, initialize the UART. You put a simple while loop. Okay. And you copy this uart underscore send string. I'm going to send string hello. And this is for slash n and slash short for the next line. Compile the program. Okay, I have compiled this program. I will explain the code. Like I have initialized the uart code here. While of 1, this will send the string hello continuously. Okay, so I will explain the code again. We have 3 functions. One is for uart initialization. There in uart initialization, we have configured 4 registers. The tmod registers th1, scon, and tr1. And then we have txchar to transmit the character. Okay, to transmit the character like sbuff equal to data. We move the data to sbuff, and it transmits the like it transmits the data to sbuff till it completed. It has to wait till it's completed. You send the string here. Send the string. Okay, this function is to send the string. Like it gets the pointer from string, and this for loop will continue till the end of string. Till the end of string, still it becomes empty. Okay, when I equal, it starts from I equal to 0 until the string becomes empty. Like it sends the all character to uart tx underscore char. So let's check the program. Go for project flash, configure flash, go for the output, choose create hex file, okay, and then rebuild this target. So now if you check, you got the hex file here. On the objects, you got the hex file. I'm going to load this hex file. I am opening note on ISP utility. Okay, so I show the output. So if you check now, like I'm going to load the file. First change the path toward hex. Okay, so click update chip. Click update chip, and you have to press reset. Once you press reset, it detects the 8051 and erases the previous program, and it loads the program. Okay. Now once the programming is done, it will give you, it will show you a message, chip is successfully updated. Click OK. Click OK. Close this one. Okay, and it just open. Like it has to be like I'm opening this serial port. I'm opening this serial port. I'm opening the serial port. I choose the COM port. I choose the COM port. Go for terminal. Okay. So I reset the processor again. Close COM port and open COM port. So if you check here, hello is displayed. Okay. Hello is displayed. I close this port. Clear the screen. I just open the program. I just open the program. Okay. So I just change this word to hello world. Okay, hello world. Recompile the program. Recompile the program. Minimize the program. And I'm opening the. I have to close this COM port, and then I have to open the Nuvoton ISP and IC utility. Once I open this Nuvoton software, okay, I choose. I have to program this one updated code. I have to program the updated code. So load file, Uart hex, okay, and I'll load this update chip. I'll give update chip. I have to press reset so that it directs 8051. Okay, and there is the previous program and loads the program. Once you will get this message, chip is successfully updated, click OK, click exit, and then you open the COM port. Okay, you reset, close COM port and open the COM port again, you got hello world. Okay, so assign pin assignments on 8051, like I'm going to connect P2.4 to chip select. Okay, and clock I'm going to use 2.5, port 2, I'm going to connect chip select to 2.4 and 2.5 to clock and 2.6 to master and slave out and 2.7 to master out slave in. Okay, this is the connections pin assignments. This is the circuit diagram where I'm going to connect the part meter here. Okay. So the first is you have to set the configuration bits. So config bits and channel selection. So we 0 1. Okay, we are going to use single-ended mode. Single-ended mode, like channel selection. If it is, I'm going to use channel 0. So it should be 0 1. So 1 0 0 1. So that is the value which I have to transmit here on D in. Okay, so this is the timing waveform. First, you have to make the chip select signal as low for a certain period of time, and then you have to transmit the clock, serial clock. Okay, and then you have to send D in first. You have to send 4 bits of start bit, and the next 2 bits single-ended for single-ended mode. Okay, a single-ended mode like SGL and odd and channel selection bits. MS and channel selection bits you have to send. The rest is don't care. So it will out the data, 12-bit data at D out. Once you send this D in, then it will out the data. Then this process has to be repeated again and again. Like after sending the 12 bits, you have to make the chip select pin as high. Chip select pin as high. And you have to like it has to be repeated. So this is the timing waveform. Timing waveform of this one. Okay, for both clock low as well as clock high. So this is the output code, like V in divided by VD, 4096 into V in divided by VD. So V in is the unlock input voltage. If you give and supply voltage, VDD is a supply voltage. Okay, this is the output code which you will be receiving. Okay, so for us, we have to if you choose channel 0, you have to send A0. If it is channel 1, you have to send D0. Okay, channel 0 is A0 and channel 1 is D0. This is the timing waveform. I will explain you the code first on the presentation, and then we can go for the demo. Okay. 51 hash input reg 51.h, stdio.h. I will change this 51.h, and this is ADC underscore CS. Okay. ADC underscore clock. Like chip select clock and D0 and DA. I have configured the ports 2.4, 2.5, 2.6, and 2.7. And this is same thing. We are going to display that on a baud rate, that on a Uart, the ADC value to the Uart. So we have to initialize the serial port, and read ADC is a function. To initialize the serial port, it's same thing. Okay? We have to configure the 4 registers: the SCON registers, the TMOD registers, and TH1 and TR1, which we covered up in the previous experiment. Setting up the serial port and the baud rate and everything, and read ADC. Like I'm going to use the chip select, like ADC chip select and ADC chip select. First, you have to transmit the chip select pin as low. Okay, as per the timing diagram, make the chip select pin as low first. Okay, low first to read the ADC, and clock is also 0. ADC clock is also 0. To make this clock as 0. Okay, chip select as 0, and clock is also 0. Okay, and then you have to. This K++ is for delay to make a delay of 2 microseconds. Okay, and you have to set the channel. Channel is A0. Okay, if channel is 0, you got A0, and you have to write the 4-bit. Like you have to send the 4-bit in DA. Okay, you have to send the 4-bit in DA, like ADC underscore DA, like channel this 80. Okay, 80 is is the MSB will be 1 if you check the binary value of 80, the hexa value of 80, the binary value of this hex value 80, you'll be getting the MSB bit as 1. Okay, you do a AND operation, logical AND operations, and like you when you ADC underscore DA, like you get the data on the DA. Okay, you have to send the first 4 bit. This 4 bit you have to send. Okay, this 4 bit you have to send, which is on the channel A0. This channel A0 you have to send. Simultaneously, you have to give the clock as clock equal to 1 and give a delay at 0. Okay, this has to be repeated for 4 bits. 4 bits. Again, you give a clock for 2 microseconds. Okay, you give a clock for 2 microseconds. You give a single clock, and then you go like, and then like you receive the data for 12 bits. Okay, you give the clock, delay to 2 microseconds. You receive the clock for 12 bits. You append this value to ADC result and return this ADC result. Okay, so you receive the value of read ADC and you print it on the Uart. I will explain the code one more time on Kale so that it will be very clear for you. I'm opening Kale now. So I create a folder called ADC. I copy this path, new microvision project. Okay, okay, project files. I choose a chip. Choose a chip. Okay. Add new items to the group. I choose a C file here. ADC. Okay. First, you have to make this chip select as low. Okay. You have to make the chip select as low here. Low. Clock is also low, and then you have to send the D. Okay. So first, I have make this chip select as low. This is to introduce delay for 1 micro. Value equal to 0. The 1 and 0.